whenever. Alright. Tell me when you're ready now. 1, 2, 3.
Yeah.
Ready?
Yeah.
Alright, so first, whenever we're working on any computerized control circuit, electronic control circuit, motor vehicle electrical, here we have our instrument cluster. And all of these lights that we're seeing in our instrument cluster, it is controlled by its own module. And if we should see the engine check light, the supplementary saying system light, the EPS light, this is a fuel level. If I should turn on the park light again, look over this side, we have the ABS, skid control, stability control. So all of these lights operate by a car computer. But what we're focusing now on is the engine management, or better yet, the powertrain management system. That's why we get the P code. Alright, so if we should start this vehicle, all of these lights supposed to be out.
Wow.
The fuel light is still on because the fuel is low. The engine check light is gone, that means it is working. And if I should release the handbrake, aka foot brake, it is gone. And if I should put on my seat belt, that light is out too. So this is showing that a system is working properly. But what will happen now if the system is not working properly? We will have a check light in, since we're focusing on powertrain management. So if the system is not working properly, we'll have something like this. I'm going to disconnect something and show you exactly what will happen. Pause. So this check light is showing that there is an electronic failure that is happening in the vehicle. This check light, yes, this light right here, I can release back. This check light is showing that there's an electronic failure. How would we fix something like this? Well, the first thing, some people might say, just go to the scan tool and scan the vehicle, and whatever code pop up, you take it from right there. Yes, that is one method, but the first thing, the ideal thing and the best thing to do is to do a visual inspection. Just visually inspect it. Reason being, you don't know if person have done conversion on the vehicle, and when you fly the bonnet, when you lift up the bonnet, you will see all type of wire underneath the vehicle. If you see all type of wire underneath the vehicle, don't use a scan tool on it, because it might destroy your tool. A tool can cost anywhere, a good tool can cost anywhere from probably 200 US to even 2,000 US dollars, and you destroy your tool. So first, just do basic visual inspection. Alright. What I showed you earlier are the various sensors that all they are connected up together. Right underneath this gas pedal right here. Can somebody let me a phone light? Right underneath this gas pedal right here. These newer model vehicles, we have a thing that we call a pedal position sensor, and these are what test the load. Let us see now. Alright, good. Lend me the
Then in the camera.
Flashlight already breaking.
Alright. So this is what our pedal position sensor look like. There we have the gas pedal, and in this particular case, our pedal position sensor right here have approximately about 6 wires. Alright, and look on the wire loom. All of this wire loom right here. Well, come here, going underneath the here. All of this connector, you notice how they like to bungle up. All of this connector, well, careful me, I disconnect earlier. All of these connector, they normally bungle up in one big fat wire loom right here. Alright, and then all of this information will go to the ECU, and then the ECU will process these information and activate things like the injectors are around here, the injectors, the ignition coil, the actuator. So these things that actually do the work is what we call the actuator. So basically, these are just the fundamental things pertaining to the vehicle. Alright, so we're going to go into the class, we're going to look on some things, and then we're going to come back out here. And it is important for us to understand what is on the board, because even if you use a scan tool and you're looking for the The scan tool not going to show you certain data that we can find. Alright, so classroom time. Alright, so we're looking at powertrain management. And you're looking at a diagram like this, and it might be complex, or it might look hard, but just tell you the truth, as what we did earlier. Remember, before we did this course, we look at electrical principle. And we look at what is an atom, what is a circuit, all of those things. And when we look at all of these things, we come up with this. So technically, all of this is a circuit. Does it look complex or does it look easy?
Complex.
All of the wire loom that you're seeing is some of these wires that bulk up in the wire loom. And that's why I said that this wire loom right here, although it's not this big wire loom right here, the circuit can easily be isolated and we'll find whatever the problem is. So, powertrain management, we're talking about engine and transmission. But powertrain management never come about just like that. First, we have computer control fuel system, we have computer control ignition system, and we have computer control transmission system. And when we merge all of these systems together, we get powertrain management. When we merge computer control fuel, computer control ignition, we get a thing that we call engine management. So that's why we come out with this term right here. Engine management. Alright? So if you're doing a course like this, and you're trying to understand people, if you don't know electrical principle, don't bother come to class and waste your time. So if you don't write down your symbols then, you don't study the concept and the principle, you're just wasting your time. And that is the problem with many of you. People don't want to spend time to learn anything, they just want to get up one and pick up scan tool and farm themselves forward. So, what is a sensor? First you have to know what is a sensor. Sensor convert temperature, physical movement, chemical reaction into electrical voltage. So all of these right here, these are your sensors. They're going to convert some physical movement, some chemical reaction, and some temperature into electrical signal. But when we have sensor, we have two types of sensor. We have active sensor. These sensors generate their own electricity. So if we are talking about a sensor like this that uses magnetic induction, I remember method of generating electricity, magnetic induction, chemical reaction, where we have a permanent magnet coil winding and we have a trigger wheel. In this particular case, we can have our cam sensor or our crank sensor generate this electricity, although this is an AC voltage. Alright? We have passive sensor now. These sensor now, we're going to need electricity to go to them. Because these sensors, they don't produce their own voltage. And as you can see, you notice on this diagram right here, you have voltage coming out of the car ECU and going back. Actuator. An actuator converts electrical energy into physical movement. So we're talking about our solenoid, our motor, our ignition coil. Ignition coil is not really a physical movement, it's really magnetism. But in automotive technology, we have to place it under the actuator. Ether element, we also have to place under the actuator, because it's really heat. And we're just talking about automotive light voltage. You have pneumatic actuator, hydraulic actuator, electro-hydraulic actuator, but we are not looking at those things. We are just looking at the motor vehicle aspect or cars. And then we have analog signal and digital signal. So, here we have a power management control system. And we have the PCM, powertrain control module. Receive signal, process signal, which we call memory, and activate actuator. So this is what our powertrain control module will do. Some people call it powertrain, some people call it the brain of the computer, and it looks something like this. And remember, this circuit now work with microchip, semiconductor device, millivoltage, low voltage we are talking about. Alright? And if you notice on the diagram right here, you will see a mixture. So, let us start from the ignition switch. Here we have the ignition switch. When the driver activates the ignition switch, then this relay will be activated. And you remember what I told you about coil winding and pour? Coil winding and pour. whenever you have coil winding and core, whenever you add a positive and a negative, what will happen? Magnetism. And we call that magnetism will take place. And if you really look on this diagram, you will see some place where it pop up again, like right here, so magnetism. Alright, this is also magnetism, but it's kind of different. So here we have the main relay or the power relay. When the voltage comes right here, stop right here. When the driver close the switch, he will send a positive. Right here is already grounds. So a magnetism will close this relay. So that's why you turn on the ignition here. Click. Notice this main relay, about 100 amps. It branches off to 1, 2, 3 sources. All of this information, or all of this right here, you'll find it where? Where would you find it? Now what? These fuse and this main relay, where would you find it? In your what? In your fuse box. So all of these little fuse, I don't think that these go beyond 10 amps. To tell you the truth. 10 amps, 10 amps or 15 amps. 10 amps. All of these fuse, you'll find it in your fuse box. Notice your actuators, which is your
Injection coil.
ignition coil, your
Injector.
on your
Throttle body.
the throttle body. And you notice I put M right here. What does the M represent?
Motor.
Very good. So your throttle body.
Yes, sir.
All these actuators, you notice they are being supplied with a positive through some fuse.
Fuses. Yes, sir.
You notice that?
Yes.
So therefore, if you should go in at the camera, you must can find a fuse where activate the injector, where go to the ignition coil and we go to the throttle body. You can find them. And you can use your LED, your logic probe or your multimeter and you find them. Notice on this side now, what does this signal represent? Up and down.
Digital signal.
It's a digital signal.
Yes, sir.
So the computer will send out a digital signal. What is it, positive or negative?
Negative.
Ground. This signal, is it a grounds control or
Grounds control.
grounds? Negative. So the computer will send out a grounds. In most cases, you have some cases where the computer can send out a plus. But in this particular case, it's a grounds. If you should look down here, so now, this is the transmission side. And notice now, we have, what is this component right here?
Gear switch board.
Gear.
Gear.
Now,
Switch or range sensor.
a range sensor.
Range.
So this now, when you're in your vehicle and you're changing P, neutral, reverse, D, this is what is moving. This is normally operated from a cable. Generally speaking, a cable, all this is a shift by wire system. So that cable that run from the transmission on the inside the vehicle and your shift park, this is what change. And if you notice this is a ground. So when you're in park, send a signal. Neutral, send a signal. Reverse, send a signal. And what comes outside out of the easy, you notice a shift A solenoid, shift B solenoid, torque converter, lockup solenoid, line pressure solenoid. All of these solenoids are grounds to the frame of the transmission.
So from magnetism would have gone this up.
So these are what's the coil winding here and the core. So with these solenoid now, a plus will be coming out of the automatic transmission to activate it. Them something here, you know, them easy, you know. A 50-year-old technology, them here, you know, and 70-year-old technology, you know.
Yes.
Alright, so here now, we have a cam sensor and a crank sensor, and this is the form of inductive pulse. We have two other methods that we can use. We can use a Hall effect system, which I don't teach you that yet, and we can use an optical pulse system, which I don't teach you that yet. This system now, each time this trigger wheel spin, it generates what?
A magnetic pulse. No.
What the computer need?
A signal.
Yeah, what type of signal? What is a sensor?
A sensor convert temperature, physical movement, chemical reaction into electrical voltage.
So what does this cam and this crank sensor? What will it do?
Produce electrical.
It will produce what?
Electrical.
What type of voltage? AC or DC?
AC.
Because we are using magnetic induction.
Yes.
You have to apply the electrical principle that you learned. And if you don't understand it, you're not going to understand it. So, here we have some battery positive 10 amps again, because normally typically a computer sometimes about 4 battery positive about it, you know, or 5 sometimes, you know. Just about one powertrain manual, you know. So if each side knocked down and locked down, somebody can back up and help out the situation. So here we have now our air temperature sensor, and typically we have 5 voltage coming out of the air temperature sensor.
Yes, sir.
Because this is a variable resistor, thermistor principle, temperature sensitive variable resistor, you will have a 0.5 to a 4.5 returning back to the ECU. So if you get a code, air temperature sensor code, and you look on current data, live data, the scan tool will not show you the 5 voltage that is coming out of the ECU. The only thing the scan tool is showing you is a signal that is entering back. So if it's a 0.5, 4.5, therefore it is working. But once you see negative, if you see negative, you have an open circuit. So all of them time when you look on data, you have to know what you're looking for. You know, so look on signal to see if them out. Some people see if them out. That's not really a teacher now. So here we have the air temperature sensor. Right here now we have the airflow meter, and we're going to put this airflow on this air temperature sensor later. Here we have the airflow meter. What type of resistor would be this airflow meter? Fixed, variable, because from day one, you will see 5 voltage coming out. You will have the ground, and you will see a signal 0.5 to 4.5. But on the scan tool, some given percentage, some given 8G, and some will give you voltage. It varies. But once you see a negative 0.5 or a negative 4.5 or negative, that means the circuit opens, a pull circuit that. Some OBD2 principle, it's a part. Some OBD2 principle, which is circuit high, circuit low, sensor outer range. But the vehicles them that we have, you know, they are not necessarily OBD2. We have JOB protocol, Japanese onboard diagnostic, like the PASO. That is straight JOB. If you are talking about the BMW and the Benz, you are talking about European onboard diagnostic, EOBD. If you are talking about some American vehicle, especially if you come from America, it is straight OBD too. So the protocol, when we use a 3 protocol, we are playing without here, we're not playing 1 protocol. So sometimes you can't really depend on circuit high, circuit low, or circuit or range performance. And some vehicle it will show. For example, even the 2005 Honda Civic. When you scan someone, then you get the option, you don't see the code, you just see the number, like 22, 4, and those things. And some scan tool can give you the option. If you have a P, or sometimes the scan tool better do it. It shows P, whatever it equivalent to, and 4, whatever it equivalent to. Because the vehicle is not really originally OBD2 to say. So you can still sell in Europe. You can still sell in Eastern Europe, Western Europe, but you can't sell in America. Because America, you have to have an OBD2 protocol to operate in their market. Alright? Coolant sensor, what you notice coming out of the ECU?
5 volts.
And how much, what range is supposed to return from where to where?
0.5 to 4.5.
4.5. Alright, good. And this is the air fuel ratio sensor called O2 sensor. And if you notice, there are 4 wires going to this O2 sensor. You know this?
Yes, sir.
If you should notice, you have a plus and you have a negative. And what does it say? Ether element. So the computer will send voltage to this ether element here, and it will warm up the sensor. Hopefully by 30 seconds to 1 minute, the O2 sensor is supposed to reach at least 350 degrees Celsius for it to become operational. Whole O2 sensor cannot work. So that's why they need the ether element for it to become operational. Range, we are looking for 1.1 to 0.9 voltage. Alright? Pedal position sensor now. I show you the pedal position sensor earlier. And you notice how many wires. How many wires I told you on the tire camera pedal position sensor? Six. Let me serve my correctly. 6. The reason why we have 6 wires, watch this. Here we have sensor 1 and sensor 2. If we have sensor 1 and sensor 2, notice how they read. Both sensors will be getting 5 voltage coming from the ECU or the DCA. But if you look on the signal, sensor 1, what is the signal return? It is what?
0.5 to 0.5.
Signal. But look on sensor 2. Sensor 2 is totally the opposite.
Yes, sir.
4.5 to 0.5.
0.5. So, when you're reading something like this on a diagram, you'll get something like this and you'll get something like this. So, meanwhile, one is rising, the other is falling. And then, as what I said now, on some system now, some will go straight to 4.5 and some will top out at call it 2.5. It depends on the system and what the manufacturer uses. Alright? So, get rid of this side down, move on. Alright, so these are the sensors. So when these sensors sense this voltage, what it will do, it will just tell the ECU how long this digital signal will stay on. Because them say I can check out from a millisecond. Alright, so it will tell the ignition time, it should open sooner or later. I don't have an sensor right here. It will tell the injector how long to open. It will tell the throttle motor what angle to move. And watch this now. You notice there is a variable resistor in the throttle body?
Yes, sir.
In many throttle body there are actually 2 variable resistors. Because when the throttle plate starts to turn, the computer has to get a signal so the throttle plate is actually turning. Alright? So when it comes down to powertrain management, this is the basic. Right here now, we have CAN wire. And why we need this CAN wire now? We need this CAN wire because we need other information from other computers to help with the powertrain. So, the AC, you need idle up and idle down. When the AC turn on, this information will come through the CAN wire and tell this computer to increase the pulse width duration of the injector, open the throttle motor because we want to put more air to come in, and also advance the ignition timing accordingly. So with more fuel, you need more what?
Here.
Air. And if you have more fuel, more air, the engine RPM will what?
Right.
Increase. And if the engine RPM will increase, you also need the ignition timing to what? Advance. So everything, so the ECU will process this information and everything will happen simultaneously. Vehicle speed. I don't have it right here. The ABS. We need vehicle speed. Why do we need vehicle speed? The vehicle speed is needed to what? To deal with what?
Transmission.
The transmission what?
Sensors.
Transmission solenoid shifting. After the transmission shifting. So if the vehicle is fast or the vehicle is slow, yes, you have to deal with the shifting. So this vehicle speed will be coming from the ABS module. Supplementary restraint system, warning, it said reduce engine power. When I've accident, you know, when the supplementary restraint system light is blinking, the vehicle will now go to maximum power and cut power. Even on the European vehicle then, once the supplementary restraint light system and even on the BMW cut power. Because what it is saying that if the vehicle should meet an accident, the seat belt and the airbag will be able to protect you. So you find things like supplementary restraint system will reduce engine power. Things like the power management system it can reduce the energy, but it's not going to really reduce the energy in the engine side. What it will do, it might probably turn off the AC, the power reduce, you need for drive to safety, the vehicle sensor, the vehicle cut off the AC, cut off the radio, start, turn off non-essential element for the engine to operate. And don't worry though, you might also make an EPS, it scares like that off too. And I don't put EPS right here. EPS. Alright? Why would you want an EPS? Angle sensor. If the vehicle is driving extremely fast, and you might just spin that, turn that steering wheel suddenly, based on the information coming out of the angle sensor, and based on the speed of the vehicle, the computer will know that this vehicle not supposed to turn so fast. It will tell the ABS, look here, cut engine power and start applying brake because this vehicle wants to go all over the place. So, since you understand the basic and I explain the basic of these, what I will do in the online class, I will explain each of these sensors and even actuators in specific details and how you can test them and check them. So we are going back to the workshop now to evaluate this specifically airflow meter.
You know how to drive it right now, my drive.
Yeah, I'm not trying to write it off my drive. So we are going back to the workshop, so we can pass that. Three. Alright. So, remember I said that we have an issue with this vehicle, foot brake. Alright, the check light is on. We inspect the vehicle visually. We saw that there was no, what should I say, no contaminants of the system or contamination of the system. People cutting wire all over the place. So, we're going to use our scan tool, OBD2 scan tool. And the connector is underneath here. Alright, good. Alright. So diagnose. I'm just going to straight OBD2 because it's a bit quicker. I don't necessarily need it. I don't need the vehicle to be running. Alright. Enter. Alright, so what we're gonna do, we're gonna read trouble code. And when we read the trouble code, we actually got 5 code. These are many code. Alright. So we have mass airflow sensor. Whenever you have several code and you get a major code, the major code are the most critical code normally come first on the car scan tool. So we have mass airflow sensor, we have intake air temperature sensor, we have crank position sensor, interested. We have mass airflow sensor again. We have intake air temperature sensor again. So we have it 5 times. So the first order of business, we can store it, more advanced scan tool, we can store it, we can write it down. Now we can just escape and erase this code, clear diagnostic trouble code and see what happened. Erase code successfully. Alright, let us read the code again. Still have 4 code. Still have the mass airflow. Alright, so let us not waste time. We can go around the vehicle and do a pinpoint test, or we can even do some initial tests right here. So we can just look on live data. Some people call it data stream, some people call it live data, some people call it current data. It depends on the tool. And let me just quickly go down to the mass airflow sensor and the intake air temperature sensor. Alright, intake air temperature. Enter. I don't have to select this one. Alright, intake air temperature. And if you notice, Alright, so here we have the intake air temperature, which is a negative 40. And we have the mass airflow, negative 40. Remember I told you that whenever we have an open circuit, it normally go to negative. We have the mass airflow, which is 0.7 GS. But we are not getting no signal. But if we should start the vehicle, I accelerate the vehicle, and there's technically no change in the reading. So what this is showing us now, this is showing us that the signal, there is no signal coming from the sensor. But based on the diagram that I showed you earlier, if there's no signal coming from the sensor, it means that we would have to use our multimeter now and test the connector of the voltage that is coming out of the car ECU or the powertrain ECU to verify this. But since we just disconnected, so that's demonstration purpose, we can just connect it back. So connect back the airflow meter for me, please. We can just connect it back, and when we connect it back, we will see the big difference. Alright, so there it is. So there we have 9.8 and we have 6.5.9, 6.8. And if we should accelerate, we should see some difference in reading in our airflow meter. Alright, and this is GS, this is not voltage. Alright, so technically this is just the basic of our powertrain management system. When next class I'll be giving you details of how the sensor and this actuator, how we can actually test them and evaluate them. And that's it. Introduction of powertrain management.